Welcome to video lesson 8.3 scientific notation. Go ahead and put today's date in the top right hand corner. And our objective today is that I can identify, write, and use operations for scientific notation. So to start out with, what is scientific notation? It is a number written as a product of a factor and a power of 10. The factor must be greater than or equal to 1 or less than 10. Now, when it comes to scientific notation, we use it in math and science to explain things that are really, really big, like how huge the sun is, or to explain things that are really, really small, like cells. So the power of 10 shows all those zeros we don't want to write out. So when it says a factor, I'm just going to pick like a variable a. The product means we multiply. In scientific notation, we use the x to show multiplication. This is about the only time of the year I use an x to show multiplication. And a power of 10. So it's like 10 to the nth power, because we don't know what power it is. Then it goes on and tells us that a, our factor, has to be greater than or equal to 1. So a has to be greater than or equal to 1. And a has to be less than 10. So basically, we're looking from numbers from 1 through 9s with a lot of decimals. So a can be greater than or equal to 1, and a is less than 10. And in our power here, will be positive, and also the power today can also be negative. So negative powers are allowed. We treat scientific notation a lot like monomials, except for this one rule. We're now allowed to have negative powers for scientific notation and scientific notation only for our section. So the first thing we're going to look at is how to get from scientific notation to a standard number, to just a regular old number. And the first thing we need to do is determine if the power is positive or if it is negative. So once you decide if it's positive or negative, then if it's positive, you're going to move the decimal to the right, which makes a big number. Okay, so positive powers make big numbers. Alright, and then if it's negative, we move the decimal to the left, which makes a decimal. So positive powers move to the right to make big numbers, negative powers move to the left to make decimals. Alright, the third thing we do is make sure we count the number of power is the number of times that it moves. So whatever the power is, that's what you need to count to move it. And when I say it, I'm sorry, how many times the decimal moves. And lastly, we fill all the empty placeholders with zeros. Alright, so let's see an example of going from scientific notation to a standard number. So example 1. We're given our first one is 2.45 times 10 to the 8th. Now, what we're going to do is keep our factor, 2.45, and then we look up here to our power. Our power is positive, so you go back to our notes. Positive moves it to the right. So, we see our decimal. He's right here, and I'm going to move him 8. Power tells me how many places to move it. 8 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And then the last step tells me to put in zeros for all the empty spots. So go back through, fill them with all zeros. Then I like to rewrite the number a little bit neater. So there's 6 zeros there. And then my 2, 4, 5, there we go. And now remember, we'll start back here and put all your commas in. So this number is 245 million with all the zeros after. So our part B here is 3 times 10 to the negative 5th power. So same thing we did on the last one. We want to drop down our factor of 3. And we look right here, the power is negative 5. Go back to our instruction that says negative powers, moves it to the left. And if we have just a plain old 3, that means the decimal is right here behind him. We'd be like 3.0. So there's the decimal. I need to move it 5 places to the left. So 1, 2, 3, 4, 5. And then fill all these spots with zeros. So it's going to be a 0 there in front. So it'll be 0.000. We have 4 zeros in our 3. So those are our answers. And remember, if you want to go back and just kind of use a little bit of knowledge that we wrote down in our notes, if it's a positive power, it makes a big number. That happened. If it's a negative power, it made a decimal, and that happened. So now let's work the other way. Let's go from standard number to scientific notation. So the first thing we're going to do is move the decimal so that the new number is between 1 and 10. Remember, our factor for A has to be greater than or equal to 1 and less than 10. Alright, and then the number of places the decimal moved will be that power. Okay, and the second step is if the decimal moves to the left. Alright, so that means you took the decimal, you moved it to the left because it was originally a big number. The power is going to be positive. Same way if the decimal moved to the right, it's going to be a negative. It's going to be a decimal to start with, so it's going to have a negative power. Alright, so let's put these rules to use. We have our second example, and we have 30,500,000. And the same thing, you always want to find where the decimal currently is. And anytime you have a whole number, the decimal's always back here behind the last 0. Now we need to get this number to be in scientific notation. So I need to move this decimal to where I can get the first factor to be between 1 and 10. So if I move it here, then that number is going to be 305, and that's too big. If I move it here, it's going to be 30.5, and that's bigger than 10. So you want to move it right here between the 3 and the 0, because then that's 3 and 500ths, or 3.05. So that's where we want it, because 3 is between 1 and 10. So I moved it 1, 2, 3, 4, 5, 6, 7. I moved it 7 places to the left. So now the only part I have to write is everything to the zeros. So my new factor is 3.05. So that's my A, and then I have to write my setup. It's times 10. Now for the power, I moved it 7 places to the left, so that means it's going to be a positive 7. Also, you can go back and say it started out as a big number, so therefore I have a positive power. Alright, now our second one has 0.000781. And this one already shows us the decimal. I already know where it is. Now we need to figure out where it needs to be to make our factor between 1 and 10. So if I move it here, it's going to be 0.7, so that's too small. So I put it right here between the 7 and the 8 because 7 is between 1 and 10. So I moved it 1, 2, 3, 4 places to the right. So once again, we just write all the non-zeros to that number. So 7.81 times 10 is always a standard, is always a scientific notation setup. And then my exponent, because I've moved it 4 to the right, it's going to be a negative 4. And also, if you start out as a decimal, your power is going to be negative. All right. So that's getting from standard form to scientific notation, or from a standard number to scientific notation. Now, we treat scientific notation like a monomial. So the first thing we're going to do is just to make sure we use our rules for multiplying, raising to a power, and dividing on scientific notation. So the same rules we have for monomials, we use them on scientific notation. One thing to keep in mind is that your A is going to be your coefficient. So your factor in front is going to be treated like your coefficient. So when you multiply your monomials, you multiply your coefficient. Okay? When you have your times 10, the whole thing gets treated like a variable. And lastly, your n, which is just your power, gets treated like a power. So when you multiply monomials and you multiply the coefficient, you add your powers. That still holds true. Right, then the last step is to make sure that the number in front, which is, remember, your A, is always between 1 and 10. If not, we may have to adjust. All right, and once again, just a quick reminder, negative powers are allowed. So here's our third example. It says evaluate 5 times 10 to the negative 8th times 2.9 times 10 to the 2nd. So once again, we treat them like multiplying monomials. So I multiply my coefficients, 5 times 2.9. And then I keep my times 10, treat them like the variable, like an x. So times 10. And then we add his exponent, so negative 8 plus 2. And that should have been 2.9. So 5 times 2.9 is 14.5. And then drop down your times 10 because we treat him like the variable. And negative 8 plus 2 is negative 6. Now our last step is to make sure our A factor is between 1 and 10. So 14.5 is big, it's bigger than 10. So this decimal here actually needs to move one place to the left to make it 1.45 times 10. Now because I moved the decimal, I have to adjust my power. And because 14.5 was bigger than 10, I have to add 1 to it. So negative 6 plus 1 is negative 5. Also, where you moved it to the left, left is positive. And positive means plus. So plus 1 down here means you have to add a plus 1 to your negative 6. All right, and our last example has 1.2789 times 10 to the 9th all over 5.22 times 10 to the 5th. So we still use our rules. We divide our coefficients. So 1.2789 divided by 5.2, and it gives us 0.245 times 10 drops down, and when we divide, we subtract our power. So 9 minus 5 gives us 4. So once again, we want to check, make sure our number is between 1 and 10. And he's not. .245 is less than 1, so I'm going to have to move the decimal here to make it 2.45. So I took it to the right one. And 2 is between 1 and 10, so we're good. So 2.45 times 10. And once again, I have to adjust my power now. So where it's a decimal and I had to make it bigger, I had to make it a negative power, so -1. Also, if you remember, if we move it to the right, it also makes it -1. So 4 minus 1 is 3. And that finishes up for our scientific notation, writing it, and performing operations with it. Thank you.